Hello, everyone, and welcome to this month's edition of the MassTimber webinar series produced by MassTimber at MSU and the Michigan Forest Biomaterials Institute. Today's topic is the Kendeda Building, Nail-Laminated Timber and the Living Building Challenge, and we are very excited about this conversation today and welcome all of you here. Thank you for joining us. This conversation is being recorded, so you can watch it again if there's something you missed, or feel free to share it with your colleagues and other folks who you know will be interested in this information today. As I said, we are the co-host of this webinar, MassTimber at MSU. This is a collaborative program across the Michigan State University Department of Forestry, the MSU Extension, and the School of Planning, Design, and Construction. We mobilize education, science, outreach, and communications to really work to advance mass timber construction and manufacture here in Michigan and the surrounding region. My name is Sandra Lupien. I direct the MassTimber at MSU program, and I am your host today. And again, welcome. Our co-host for the webinar series is the Michigan Forest Biomaterials Institute, MIFB. MIFB is a nonprofit organization that fosters sustainable forests, communities, and economies through innovative and responsible production, use, and recycling of forest biomaterials. They mainly serve as conveners and educators, it's an independent and nonprofit organization driven entirely by volunteers. So MIFB is an amazing organization, and it's our honor to co-host this mostly monthly webinar series on MassTimber with our partners at MIFB. So today, just a few webinar logistics. This is a Zoom webinar, a little bit different from a Zoom meeting. When you join this call today, your microphone was automatically muted and your video is also off. The chat function is turned off. We can chat out, but audience members can't chat in. Instead, if you'd like to communicate with our team behind the scenes, please use the Q&A function. You can use that for both technical questions and technological questions, or for subject matter specific questions that we will address in the question and answer period after the more formal part of our presentation today. And speaking of our presentation, this is the part that you came for. So this gorgeous building that you see on your screen is the Kendeda Building for Innovative Sustainable Design on the campus of Georgia Institute for Technology in Atlanta, Georgia. This building is the 28th building ever to receive full certification under the Living Building Challenge. And most of you probably know that's the most rigorous sustainable building framework currently in existence. By incorporating MassTimber, they achieved some key elements related to achieving the certification, but not just any MassTimber. You'll hear today about how, about the particulars of how they sourced MassTimber to fit within this Living Building Challenge framework, as well as about the innovative ways the project team incorporated nail-laminated timber to address the Living Building Challenge's sustainability objectives, but also its social equity objectives in a really interesting way. So as I said, I am extremely excited to dive into this conversation. Here to share with you his insights and experiences and lessons learned on the Kendeda project is Jimmy Mitchell. You see him there on the screen. Hi, Jimmy. Jimmy is the Senior Director of Business Development at Skanska, USA, where he was a core member of the Kendeda Building project leadership team. He joined Skanska in 2005 with a bachelor's degree from Georgia Tech, where then he got to build this amazing building, which has to be a pretty cool feeling. And since sustainability is a career passion for Jimmy, he was one of Georgia's first lead managers. He created the Atlanta Mission Urban Garden. He's a founding board member of the Life Cycle Building Center, which is a construction material reuse nonprofit based in Atlanta. And you'll hear him talk about how close that issue is to his heart and how that reuse ethos played into building the Kendeda Fund project. So with that, Jimmy, I'm going to stop sharing my screen and ask you to start sharing yours and take it away.
Thanks, Sandra. All right, so I will share. So just to recap what Sandra already has, this is about the Living Building Challenge aspects or lens of MassTimber and our nail-laminated timber story. So generally, I could go on hours talking about the Kendeda Building, but this is really fun to get to dig into kind of a specific topic. And so we'll dive specifically into that. And so this presentation is great because it's unique. It's just for this group, and should be a lot of fun. A couple of things that I've heard that there's some folks from like LAS, Ben Ritterboss, who was on the project early and now is up in Ann Arbor, Michigan, is I think on the call. And just generally speaking, the design team was Thordick Sargent Miller Hall partnership, and we had a ton of great other design team members on the team. But when you're talking about MassTimber, you also can't go without mentioning Usen Case, the structural engineer. So it was a great honor to get to work with all those folks. So that picture is great. The building is built. It is the 28th living building, and with Living Building Challenge, there's a 12-month measurement period, which is a little bit of difference with LEED. And so after it's done being built and it's fully occupied, we have to prove out the energy and water requirements, which I'll get to in a minute. So this is a photo early on when the building was open by Georgia Tech. It hosted a ton of events, and currently, if you walk through there now post-COVID, it is filled with students. So the program, it's not only a Living Building Challenge, it's a relevant program. We have 150-person plus auditorium, a couple of very large classrooms, 4 class labs, a 16-person office space, and it really is a student common. So lots of students come in and out of here to do things like study and relax on campus. So it is heavily used. It is not it's not something it's not used. People use it every day, and it's very active. So it is being used when we accomplish all the tough requirements of the Living Building Challenge. We have pulled it off. But as I mentioned earlier, we're going to dive deep into the MassTimber aspects of it. I like this photo. It is of course, middle construction photo. And the two aspects of the MassTimber structure here, which we will talk about, are generally the glue-laminated columns and beams, which you see mostly here, and then the nail-laminated timber flooring, roofing, or decking material. And you can see one of these roughly 10.5 by 6 foot panels being dropped in of the nail-laminated timber here in place. So what I'm going to dive into mainly in this is just talking about those aspects. So the Kendeda Building was a gift from the Kendeda Fund. They gave $25 million. And the Kendeda Fund invests in transformative leaders and ideas. So typically they actually don't invest in something like a building. But in this case, the Living Building Challenge was the accomplishment that, in building this project, there would be transformative leaders and ideas spread across the Southeast of the United States and hopefully the rest of the world. One of the other things that has happened, the Living Building Challenge was created out of the Northwest, the Seattle, Washington, Portland, Oregon area. And so the climate there is a little bit easier to achieve some of the requirements for the challenge. And then in the Southeast, with it being hot and humid, another aspect I think of Kendeda was if we can do it in the Atlantic climate, we can kind of do it anywhere. So another aspiration for the project. So the Living Building Challenge is like the metaphor of a flower. Basically, it's the concept that the building is regenerative. It gives back more than it takes. So things like the building generates more electricity than it uses. The water systems send water to the aquifer as if the building doesn't even exist. And in fact, it is better than that. It cleans water on the way to the aquifer. And then from a pollution standpoint, a waste standpoint, it's actually like net negative waste. The fact the building exists, there's less materials in the landfill. So that is big picture Living Building Challenge. when it comes to the MassTimber, and these in this case, the glue laminated columns and beams and the nail laminated timber decking system, one of the things that happens with the challenges is there's these 7 petals, the metaphor of the flower: place, water, energy, health and happiness, materials, equity, and beauty. And within these 7 petals, there are 20 imperatives. And one of the defining differences of the Living Building Challenge, the full certification of the Living Building Challenge, is you have to do all 20 imperatives. And when we make design or construction decisions on these types of projects, there really is no way to make one choice that only does positive aspects to these 20 imperatives. They tend to be ones that do, some positive and some negative. And then we find ourselves in a situation where the ideas that make it through into the building are the ones that maybe positively impact 4 or 5 imperatives with only having negative consequences to one of them. So I went through the list of imperatives in the MassTimber. The structure here impacts these 4 petals, which make up a big part of the program. It includes a good list of the 20 imperatives. And so, but in particular, of course, beauty is one, but materials is really the most impacted one. And so I'm going to do a deep dive into the 5 imperatives of the materials petal. And so, so within the Living Building Challenge, there is the red list requirement. And basically, this is the effort to get harmful chemicals out of our buildings. Okay. And so there's a list of harmful chemicals that we commonly use in construction, some that we no longer use, like asbestos, that are on the red list. And we essentially can't use them in the project. Now, this diagram here is thanks to Stacy Smedley and Chris Elstern from Skanska and Miller Hall, put together a diagram of the red list process. Essentially, what we have to do is every material that goes into the building is tracked, and we do a research paper to ensure that there are not red list chemicals in it. So when it comes to the MassTimber, one thing that's nice about it is the base material is quite simple. It's wood, right? It's fiber. It's a natural material that is not a red list issue. Now, there are natural formaldehyde, and formaldehyde is on the red list. So we can't add additional formaldehyde that is beyond what nature provides. So we have to watch out for that, in particular for things like doors, not necessarily for the structural items. The couple of things that really mattered here for the challenge are things like the sealers. As we build these exposed structures, there is a desire to heavily seal, and we needed to generally avoid that, and we did. We did have a transit sealer that was applied as a requirement from the manufacturer to get kind of from A to B to the site. And then the key chemical of the product in the process is a glue. There's a binding glue in the glue-laminated process that currently in the market is a monopoly by Hexion. And so part of the Living Building Challenge is it's a platform for advocacy. And so if things aren't perfectly disclosed, you can never find yourself in a situation where you can't do something typically, but you have to take it to the point where you learn who to advocate to. So in this situation, the Hexion glue product is not fully disclosed as what would perfectly comply with the standard. So we have to advocate to other manufacturers to come up with a product. It happened to be one in the market that there's a monopoly. And so we wrote a letter to the manufacturer Hexion saying, hey, as far as we know, you're good, but there's some things that are undisclosed here that are not 100%. And we actually had to send them this letter. So that's on the glue laminated side. For the red list on the nail laminated side, it was a little bit easier. We had salvaged wood and new wood. There again, it's just wood fiber, and we avoided adding a bunch of chemicals or sealers to it, and we consciously made the decision to not do that. So that was an impact of the red list that on a non-Living Building Challenge project. Might have gone a different way. Might have had a few extra sealers. And one of the things about that happened ultimately is we did have a heavy raining season during our erection, and we had some more sanding than we would have done, I think, if there were some extra sealers on there. So that was one impact on that. All right, for embodied carbon in the materials pedal for MassTimber. So generally speaking, this is a big positive. You know, MassTimber is one of the embodied carbon is one of the reasons to select MassTimber. You know, this is a snapshot of our EC3 tool that the Carbon Leadership Forum out of the University of Washington has put together. And so I grabbed a cubic yard of timber, of pure wood, and the baseline there is 159 kilograms of CO2 to do those, you know, those phases of the embodied carbon world. And concrete and rebar for essentially a cubic yard of reinforced is going to be more like 450 kilograms of CO2. So we're at a 3-4 times multiple just on that, and that of course excludes things like the bio pieces, where clearly if you're growing timber, then you're that product is breathing in carbon dioxide and exhaling oxygen, and so that would exclude those benefits. So if you include that, of course, it's even a bigger reason for embodied carbon. So MassTimber is a Living Building Challenge. They work really well together on this particular imperative. Generally here that is a wood fiber issue, and it's the same for the glue-lam and the nail-laminated. But one thing that is unique about this project, and I'll get to this more detail later, is we salvaged 2x4s, and there is not a lot of data on the carbon impact of salvaging materials, and so fun enough, we did a ton of data collection on this project, and we salvaged 28 different materials in the building and tracked everything about that process. And we shared all that data with Michigan State, and Kendeda actually funded a small study with Michigan State to figure out the impact that the salvage had. And so we can do a whole other webinar about that embodied carbon study with Michigan State. But we essentially generally about every pound that we salvaged reduced about 1.5 pounds of carbon dioxide emissions. And this nail-laminated timber was a big salvage story for us. So, okay, the next item is responsible industry within the materials pedal, and that is FSC certified. So, Forest Stewardship Council. And this had a major impact on the project because FSC, since I guess the Brazilian rainforest days of the 90s, has in the early 2000s to maybe 2010ish had a lot of popularity, and then there's been, I guess I would say, quite a bit of backlash against FSC. Now, recently it's interesting with some of the stuff that's going on in Brazil, maybe it could come back, but for us at the particular time, it was complex. It really added a lot of logistical burden to source FSC, and we did. And so the other thing is living economy, and I give a little Google Earth maps here showing some of the suppliers. And the FSC story is involved with this. So the red mark is the Kendeda Building in Atlanta, Georgia. Our glue-laminated supplier was out of Florida, Universal Timber Structures, and they were FSC certified. For us to find FSC certified wood for our industry, we actually had to go to Arkansas forests. It's interesting, the ones in, say, Georgia and Alabama for other industries are set up for FSC, but currently not the construction. So we generally for that, our southern yellow pine came from Arkansas forests. Then they went up to Unilam in New York to get fabricated into glue-lam, where that Hexion glue was used to, press the beams and columns. And then the final fabrication was there in the Panhandle of Florida with Universal Timber Structures. On the FSC 2x4 side, for the nail laminated in 2x6. We actually did source some of that from Alabama and Georgia. That was FSC. It was a little bit easier to source that than the glue-lam at that particular point in time. And then all the salvaged wood came directly from the film industry, local to Georgia, local to Atlanta, actually. So that was all sourced very closely. And so to just describe the living economy, there's a certain percentage of materials that have to come within 500 kilometers, and then 1,000 kilometers, and then 5,000 kilometers. And so timber quite often is something that can come within the 500 kilometers, and we can take advantage of that. I think it is a great structure type. Quite often the structure materials do come locally if it's concrete or timber. Steel may come from far away distances. Okay, and then net positive waste, as I mentioned already, we here again in the materials pedal, we took advantage of this, and I'll get into that in a minute, but we salvaged over 25,000 linear feet of 2x4s from the film industry in Georgia. We identified that and incorporated them into the nail laminated timber piece, not into the glue-lam piece. That's all new FSC wood, but a portion of the nail laminated is salvage. And like I said, that helped for many reasons. So as you can see, that just within the materials pedal, MassTimber impacts every imperative within it, and generally in a positive way, though maybe with the disclosure of the hexagon glue, it is a negative, but something that we can advocate for. So now to focus a deeper dive into the nail laminated timber. So this image is from the Revit or Assemble model efforts that Using a Case would have put together, and everything that's kind of in the brown here is a nail laminated timber scope item. And so one thing I have to say about it is that the columns and beams from a pre-con and estimating standpoint was very normal market experience. It was predictable. The pricing was somewhat similar. When it came to this decking material being ton and groove or cross laminated timber or nail laminated timber, it was quite we received quite a wide range of possibilities, and honestly, just the pricing did not come in as anticipated. And so it really became something that was going to make or break the project. And we, in particular, mixing in the FSC requirements, we just were not getting bids on the nail laminated timber side at all. And we did have one qualifying bid out of Canada that was for $1.1 million, and it was just too much for that bit of the scope for the project to handle from a budget standpoint. So a few of my friends like Cale Gasly and I, we went to Home Depot and bought new 2x6s and 2x4s, and did a mock-up of what one panel would look like. And to back up a little bit, I need to give a shout out to the Bullitt Center in Seattle. This was a project that was a precedent project before the Kendeda Building, and they had done nail laminated timber there and ran into the same situation where the pricing was a bit erratic and they had to do it themselves. And they ended up nailing 2x6s one at a time into place. And when I talked to the project manager from that project, he said that he would have penalized them if he had the opportunity to do it all over again. So at that point, we were looking to penalize them as well. And so it was relevant to do about a 12-foot by 5-foot panel to figure out how productive we could be at making this, this kind of new process for us. And so we got a nail gun and built one panel on the floor. Essentially, it's upside down when you build it. And it took 43 minutes and 5 seconds to build this one panel. We then, we calculated the linear footage of 2x6 and 2x4 we would need. We had a price for what the salvage would be, worked up with our local nonprofit, the Life Cycle Building Center, who was the nonprofit that was had the relationship with the film industry that was collecting the salvage 2x4s. So we established the material costs with what was new or what was salvaged. So we knew what that was. And then we just needed this mock-up to figure out the labor cost. And we knew we needed to build about 488 panels. And we took this time with like a crew of 4 folks and did a labor rate with labor materials. We came to a price that was more like $300,000. So we reduced the low bid by $800,000, and this was a big turning point for the project in terms of value engineering and getting to the GMP to make it all happen. So one other thing I've got to talk about the progression of the nail laminated and how we use salvage. At the Bullitt Center, they have a taller office building that has a different fire code situation for them. And one thing about wood is that it is actually it performs quite well in fire when it's thick. And so in their situation in Seattle there, when they had that class of fire code, it required a thicker piece of wood. And so they actually needed 2x6s across the board for their entire NLT system. The Kendeda Building is not as tall, and we actually don't have the same class of fire, so we were allowed a 2x4. And structurally, it kind of works out that every other member is redundant. It's not really needed or a factor in the structural calculations too much. So what that allowed us to do was think through the 2x6 could be the structural member, and then a 2x4 could be a spacer that was salvaged. And it essentially, through the structural model, was not a factor in the structural calculation. And so that is how we were able to salvage a lot of 2x4s into the nail laminated timber structure. Here again, you can add things like acoustics. With Living Building Challenge, you tend to have concrete floors and no ceilings. So you need wall panels and things like this, acoustic wall panels. And this fluted design was a factor and another benefit on the acoustic side. So the makeup of this was quite fun as a team between all parties, really. And I have to say, as a contractor, we were able to put everybody's vision together and make it all happen. And it really was a first in the industry. So so it's fun to be a part of it and be the guy who made the mock-up and was nailing it with a few of my coworkers. So, okay, so to get more into the process, we have for the nail laminated timber, in order to save that $800,000, we did it ourselves, which is a bit unusual. And so Georgia Tech gave us free access to a warehouse that they have about a mile from the project site off of Northside Drive. And so we roped off a section and started salvaging materials and created essentially a small manufacturing site for the nail laminated timber. So here's a photo of some FSC wood that was new material. And on the side, you see a few pallets of scrap 2x6. So this is an interesting story, and I'll show you in a minute. When the building was right sized with the program, the structural bays landed at 10.5 feet. And we buy boards at, up to 10 or 12 feet. There's no 10.5 foot board we can buy. So as soon as that happened, we told the design team, we're going to end up with like 10,000 pieces of 18-inch 2x6 scrap. And so we'll get to that in a minute, but they ended up designing that into the building instead of making it a waste product. We made it a material for the building product. So so that was the new source of wood is FSC, both 2x4 and 2x6. And certainly all the 2x6s were new FSC. Then we collected as much 2x4 salvage as we could through the film industry and Life Cycle Building Center. Just by the way, the shows that were a part of it were the show 24 and the movie Rampage. And there was also a middle school educational seminar that we received some material from. They just to describe the process, they build these 5 or 6 foot tall sets. And then when they're done, let's say they shoot for 3 months or so, they strike the set. It's actually a very union-based group, and they throw all the material away. And in this case, Life Cycle Building Center can step in and fit in with the union in the right spots and grab some of these 2x4s. So we did that. So that mock-up that I made, of course, was garbage. It will not be used in the building at all. It was not. But we had Senior Superintendent David Luffel did an amazing job with creating our own shop drawings, understanding where each of the panels would go, and it ended up landing at 489 panels, not 488. And then he made a plumb table that was at waist height so that the team could be very productive. And we needed to hit 8 panels a day to hit our 8 to 10 panels a day to hit our estimate. And so here's a shot of one panel being completed, and then here's a shot of the side being cut down with the 2x6s. This particular one must have been over the elevator because he's clearly not cutting off 18 inches, but most of them were cutting off 18 inches. And here is a photo of where those pieces of 2x6 scrap were incorporated. There are 6 or so different areas where these stairs are included, 3 major ones. This is one of the major ones. And then a couple of spots that are small stairs where we essentially turned the 2x6 scrap into a butcher block stair. Here's a great shot of David taking one of the panels, and right here in the background on the right is a gentleman, Kendeda Daniels. I have to talk about him as well because in this process, as I mentioned, the equity pedal was one of the pedals I circled. And though there is no imperative within the pedal directly related to MassTimber, we took this in the spirit of the equity pedal. We did a study with Georgia Tech. We actually had a few meetings with Georgia Tech to talk about how we can uniquely impact equity through our project. You know, being in Atlanta, kind of the home of civil rights, we wanted to do more than just the requirements. And so there's Chris Burke from Georgia Tech had done this study where he had uncovered a few neighborhoods around Georgia Tech's campus that were underrepresented in the employees of Georgia Tech. So they have, say, 7,700 employees, and there's a smaller percentage that should have been in a few neighborhoods that work there. And so we identified those 3 neighborhoods and looked on the map, and we found a workforce development nonprofit called Georgia Works. It was formerly incarcerated or homeless men. And David and the team trained those folks for only 50 cents more an hour compared to the carpenter labor rate. We were able to engage with the workforce development program at Georgia Works. So for the 3 to 4 months that we were in production on these panels, we trained 6 of the Georgia Works men in the program to help them with a great construction resume item. You know, it was a great benefit of the whole project, and the beauty of the building is really imparted to some of those individuals. So this is a nice shot that shows how detailed each panel was, and each panel was matched up with the shop drawing, and we knew exactly where it was going to go as it was erected structurally. And this shot shows a lot of the panels before install. There were all to the left. There's more like this built up, and so we had 489 of these things ready to go. And I have to say, in comparison to the glue lam, the nail lam process for us, because we owned it and had to process the material months and months in advance, the FSC supply worked out better for our own NLT process. When it came to the glue lam, we all knew FSC would be an issue, and it was discussed constantly, and we took all the precautions. We really did. And then it came to supplying the FSC for the glue lam, and we experienced a 50-day delay in getting the material for the glue lam. So that was one of the tough schedule items for the project that we were able to overcome, was a 50-day holdup per the FSC on the glue laminated columns and beams. One thing I've got to say about that is the Universal Timber Structures that did the erection for their columns and beams, they also did the erection for these panels on their beams, and that was a bit of an unknown for us. We estimated that maybe we could do, I don't know, let's say 12 a day install, but that was an area that we excelled at really well. The foreman challenged his group, and he said, "I'm going to give you guys pizza if you can hit a bigger number." They ended up installing 54 of these panels in one of the days. So it's quite incredible how much more efficient panelizing it was compared to doing something else, to be able to install 50 of these in one day. So here again on the equity pedal, these are a few of the men involved with the Georgia Works program. And on the right here was Kendeda graduating from the program, and we attended that in support of Kendeda. And so that's a deep dive. I wanted to leave some time for Q&A with Sandra, and let me see. We've got here from Michelle. FSC was used, but is there a reason SFI was not suitable? So yeah, this is a good question. So the reason why it's not suitable is because the Living Building Challenge says it's not suitable. Honestly, I can't speak for them, but SFI, maybe there is a future where that is discussed and it becomes an option in the future. But at our point in time, it was not an option. I personally, it is interesting to think about, and I think it's, when you think through it, it's one of the reasons why maybe politically a lot of states kind of went away from FSC and why it lost some of its momentum. I'll give you a personal story in this. I have a small group of college friends that we have an investments club where we put in $50 a month, and instead of going to the bar or something, we do an investment. And over the years, we ended up buying into a tree farm in South Georgia. And the whole purpose of this tree farm is that there's the kind of the invasive loblolly species, and as they harvest the loblolly, we're replanting longleaf pine, which is the native species. So the whole objective of this farm is simply ecological. And we are not FSC certified, but we certainly would be if we made an effort to do that. So it's an interesting argument, but if you think you take a step back and you look at like the global level, and you think about like the Brazilian rainforest and whatnot, I don't think SFI has an impact on that. And so I think it's maybe a little bit more of a global issue there. So I'm not the right person to answer that, but the folks at FSC would be.
Yeah, Jimmy,
yeah.
I want to thank you for your presentation, and then
okay.
I want to move us into more of a conversation and Q&A format. So first up, would you mind stop sharing your screen so we can see your face better? There you are. Hello. I am so inspired by your presentation. I learned about this project earlier this year. I'm a little bit of a late bloomer on this project, but I've become a super fan of the Kendeda Building. And all of the different ways that, you know, your team and your colleagues worked in service of the different petals, and particularly the ways that MassTimber contributed to that, and especially the nail-laminated timber model that you created and innovated. It is so exciting, and thank you for sharing that with this audience. Thank you for answering the question about FSC versus SFI. For those who aren't in forestry or don't know the difference between those two things or what that means, FSC is Forest Stewardship Council. It is often considered the most rigorous forest certification system in the world. And the Sustainable Forestry Initiative, SFI, is another one of those certification systems. And I also, like, you don't know why Living Building Challenge might prefer one over the other. That's a question for another time, but I just wanted to clarify those acronyms. So I know we're starting to have some questions come in. One question was just reminding us again where the salvage 2x4s in the NLT came from for this project. So you can briefly restate that because we have that question.
Yeah, so the salvage 2x4s for the NLT came from the show 24. The actual stage that they would sit on would be like 6 feet above the ground, and there's a lot of 2x4s in that. And when they strike the set, they tear it all down and they throw it away. But we salvaged it, kept it. And so it came from the show 24, the movie Rampage, and a middle school educational seminar, all from studios like right around Atlanta. So it all moved just a few miles away from the project site, was aggregated and collected at the nonprofit Lifecycle Building Center. And then we set up a price per linear foot of that salvage with them in advance. And then whenever they got to a bulk number, say 5,000 linear feet, we would get a pallet of salvage wood from them.
Yeah, that's so powerful to be able to salvage that quantity of wood. And I don't know if anyone else on this call had this reaction when you said what happens typically to that wood after it comes out of the film set, which is that it gets thrown away. I physically shuddered. I went, no. I mean, of course we know that happens, but hearing it so directly and understanding how brief the time was during which that wood was actually in use, and kind of the implications of just discarding it are, I don't know, it's a little ouchy. So I'm glad that you were able to use that wood. And I think that, you know, there are a lot of cases where we have access to that type of salvage wood. The film industry is one, you know, huge events like the Olympics, that's another one. You know, we have opportunities to reclaim this wood and use it for long-lived durable purposes, especially in our buildings. Also inspiring is the model, the workforce model that you used working with Georgia Works to employ people who either had been experiencing homelessness or who were previously incarcerated, and, you know, providing some training and some direct employment through this. Do you have a sense of what the outcomes have been since the project for some of those folks? Did this project help support them moving into longer term employment?
Yes, you know, we did. We invited them to the project kickoff, and it is hard to keep in touch with a few folks, but 2 of them we know for a fact are still in the construction industry, and the other 4 just instead of, you know, despite trying, we kind of lost touch with them. But who knows, maybe they moved to another city or something. Yeah.
It's good to track that and know about that.
Yeah, one Kenyatta I mentioned because Skanska actually went to hire him, and we moved him to a new project. And then he found a better offer with a competitor. so his result was pretty good at the time, yeah.
So we are taking questions, so you're welcome to type those into the Q&A box. And meanwhile, I heard a report that maybe we can't see Jimmy's video right now. So if that's the case for you, we're just trying to correct it. So hopefully we'll be able to correct that pretty soon. I changed a setting, hopefully it's rectified.
All good now,
George. My colleague George Berghorn, that it's all good now. Great, and it's George Berghorn, my colleague here at MSU in the School of Planning, Design, and Construction, that turned me on to this project and resulted in this fandom. So, one question I wanted to ask you is more of a technical question about the NLT. So, I've been really excited about NLT as a potential way to begin quickly manufacturing and using mass timber in Michigan, using Michigan wood built by Michigan folks. And when I talk to folks who are involved in the construction industry, the first question they usually ask me is, what about swelling? Is swelling a concern with NLT more than it is with other types of either floor products or other types of mass timber generally? And if so, how did you mitigate for this in this project?
Yeah, I get another shout out to David Luffel here. We did, and so basically the panel helped with that. I feel like it did, because every panel we gave a 1/2 inch gap between the next panel. And see, the assembly was every 2x6 we pre-drilled a hole for a 10-inch, 8 or 10-inch screw, and then so we would drop the panel on, screw it into the column, and then on top of that was a piece of plywood or sheathing. And so we still had a solid assembly for a floor, but it allowed the contraction and expansion over the course of a 6-foot panel, a room for a 1/2 inch for it to shift.
Oh, that seems like a lot of flexibility. That's good to know. How long have the panels been in place and in use in the building now?
So we installed them during a very rainy season, now 3 years ago.
I'm not sure if it's frozen on my end or Jimmy's end.
Can you guys hear me?
I had asked how long the NLT panels have been in place and in use in the building now. So it would be great if we could have an answer to that, but I do see we're having a technical problem. There we go.
All right, can you guys hear me? So they've been in place for a little over 3 years.
Yes, sorry about that technical.
Okay, they've been in place for a little, You are the host now. Okay, well, maybe she had the technical difficulty. Well, we had a little over 3 years ago, we installed it. So call it about 40 months ago was when they were installed. And then of course the building was dried in and complete, like say three years and say 2 years, they say 27 months ago. So it's been dried in and operational for well over 2 years now.
That's great. And sorry, my connection actually dropped. So nothing like the host connection dropping in the middle of the webinar, but I'm back now. How are they performing? Do you have a sense of that?
Yeah. Well, I would say, so there, when we had the rain without the red list issues, there were things that we had to, sand and finish to make it look beautiful. And of course, when it was dried in, we did that once and it did. It's one of the great things about wood. If something like that comes up, you can just, sand it a little bit. And so then early on, we actually, we tracked the building in so much depth in every aspect you can imagine. So we knew the moisture content. The thing that happened, it rained so much that we had a lot of water in our timber, especially without having those sealers on, those extra sealers on it. And so the most impact that really happened was early on, let's say the first 6 to 9 months. The envelope of the building is so tight and well designed and built that over time it dried out. And I think that ended up being the majority of the contraction of the building was as it dried out. And of course, and so for us, there really was there was about a phase of 6 months or so as that wood that didn't have a lot of sealer on it slowly dried out.
Great.
So at this point now, as the seasons change, you could think that there could be some more contraction and expansion, but it's going to be more limited now that the building's dried out.
Yeah, that makes a lot of sense. Thank you. Another question that people often ask me when I talk about NLT is about spans. What kind of spans were you covering with your decks?
Yeah, it was 10.5 feet, and the longest one would have been, we would have had a few cantilever conditions, and we did actually buy some 16-foot boards for in a couple of spots. Like there was this cantilever spot and an elevator shaft, for example, and they went to somewhere a little bit below 15 feet.
Great. And I'd like to remind folks that if you have questions, we still have a few more minutes. So if you want to type them into the Q&A, please do so. If for some reason the Q&A isn't working for you, you're welcome to just type them into the chat, which actually is working for incoming. So please avail yourself of either of those methods and we can answer your questions. I wanted to say one thing that surprised me about in your presentation that I didn't know was about the butcher block stairs used from the waste from cutting the boards for the NLT, and that looks amazing. And it made me wonder just if you could talk a little bit about the general reaction of people who are going into the building to the MassTimber elements and to generally the story of the building. What are you hearing from people?
Yeah, one of the most fun stories for me is I went to a tech event maybe, I don't know, a year ago, and I sat down next to a group of students and they were talking about the building. And it was interesting because, I mean, it was not like we were in the building. I mean, we were across the other side of campus. They were talking about the Kendeda Building, like a group of like 20-year-olds or 19-year-olds or whatever, which floored me, you know. I mean, I've got an 11-year-old now, and I would never think they would talk about such a thing. But and so they said it smelled great, it felt fresh. You know, I think that was one of the benefits of not having all the sealers. We nailed the volatile organic compound testing we did at the end of the project. We passed it with flying colors, and that is one of the big reasons why we avoided those sealers, right? And so you walk into the building, and it does feel like you are, I don't know, under a tree canopy, especially in that big atrium. And I think the testament from those students being hyped about it across campus, and then if I was in the building right now, there'd be 50, 60 kids sitting in the chairs and on the couches and stuff, studying and reading. They just kind of like to be there.
Yeah, that's very familiar to the experience we're having here at Michigan State University with our STEM teaching and learning facility, which, as a lot of folks on the call know, this is the first MassTimber structure in Michigan. And we hear some of the same feedback from students who are like, oh, this is not even my building. I don't even have classes in here, but this is where I come to hang out and study because it feels so great. Oh, I wanna hug these wood columns like a tree. You know, it's like unexpected feedback from the student population. And that is, I think, what we're after when we're building with MassTimber, among all of the other benefits of these beautiful environment and biophilic, enjoying the feeling and benefits of being in a wood building. Well, we're getting close to the end of our conversation, and I haven't seen any additional questions come in, but I think I'd like to ask you, and I hope you don't mind if I put you on the spot, for folks who might be encountering questions from clients about using MassTimber or building a more sustainable building. What are the top couple of things you would say people should think about if they're going to approach actually using NLT specifically in a building? How should they be approaching that process?
Yeah, well, I mean, I would, I think that NLT in this situation with the salvage was quite amazing, right? So that would be an option for you. And I don't know, I mean, like, I don't know if it would be, like, there's been quite a lot of salvage in places like Detroit or whatever, right? And so what a fun way to potentially tell that story. I think it's nice because you can do it yourself in a way. I do think long term, it would be interesting if industry would do it. But here we have an example in Seattle and here in Georgia where we both chose to self-perform it. So you can pencil it out really well. It's so simple, you can pencil it out. Something like the glue-laminated or cross-laminated, it's a very sophisticated process. You can't do it yourself, right? Nail-laminated, if you're building your own house, you could just do it yourself, And so I think from that same manner, if you're trying to judge or control your own costs, you would be more empowered to do so with that product type. Now, that being said, I mean, I hope in future commercial projects to use all types. But I think in terms of being self-empowered, the nail laminated is a benefit.
Great. Yeah, thanks for sharing those insights. Appreciate it. Is there any final thought you'd like to share with our audience today?
Yeah, you mentioned the hugging the column, and one thing that reminded me was and this is a factor of the building challenge. So and generally about the height of structures. So the current code issues how to bring up this beautiful structure, right? And so, but in addition to that, you know, I think there are some cost savings in terms of opportunities for reduction in ceiling or maybe some flooring. And what ends up happening a lot is that these structural elements become exposed, and we're not used to to structure being a finished product. And in this case, it can be, it's intended to be. And so there's some really fun in the field moments. The project team, you know, needs to build a culture around that, where, you know, we had like an electrician who was marking up conduit penetrations or something, and, you know, put some pink spray paint to mark where conduit was in the slab or something, and then ended up hitting pink spray paint on the column. And then, you know, we'd make fun of him for a few days or whatever. But he easily cleaned it off. It was no big deal. But it's kind of a fun culture where the whole building kind of acts like artwork in a way. And so it's not just something you can Sharpie on and put your notes on, because later on you're going to cover it up with drywall. If on a tall building situation, maybe that will happen some. But I think that was kind of a fun cultural aspect of the job site.
Yeah, that's a great story and a fun image. Like, oh, we think we're not done yet, but actually we are done now. So I'm going to just share my screen here and close us out. Jimmy Mitchell, thank you so much for sharing your insights about the Kendeda Building for Sustainable Innovation at Georgia Tech, and how it used MassTimber in a living building challenge building and created a fascinating and innovative model for nail laminated timber on the site. We really appreciate your participation and just value your insights so much. So thank you for that.
Thanks, Sandra.
And this has been a MassTimber webinar co-hosted by MassTimber at MSU and the Michigan Forest Biomaterials Institute. I've been your host, Sandra Lupien, Director of MassTimber at MSU. If you would like to contact me or want more additional information about MassTimber and how we're thinking about it in Michigan, please contact me. My contact information is here on the screen. We're in the process of planning our January webinar right now, which I think, not promised yet, but I think is going to be on MassTimber and affordable housing models. So looking forward to that one as well. In the meantime, feel free to reach out to me. Keep an eye on your email box for the recording of this webinar, and feel free to share it widely with your colleagues. Definitely want Jimmy's insights about this project spreading far and wide. And I hope that all of you have a safe and healthy new year as we make the transition from 2021 to 2022, and look forward to seeing you next time at our next MassTimber webinar. Thank you.